I am on board of a steamship, and we have these limitor valves that they stop or allow the steam to go through. So that's what I'm gonna cover. Before we continue, remember, if you find the material in this video too technical, please watch earlier videos where I cover basic electrical knowledge. Keep in mind that the first 28 videos are best understood if you follow their sequential order. Now, back to our video. So the valves are pretty large, and so when they open, they take a long time to open, and they got this dial that it goes from 0 to 100% open, or from 100 to back to 0%, and it takes a while. To open and close these valves by hand, it could take about 5 to 10 minutes, but with the motor, it could only take about 10 seconds, maybe 15. Limiter valves, they had these cams per se, and they work on a reduction system that is connected toward the motor. So as the valve is turning and is closing or opening, there is a set of gears inside of it that cause the cam to at certain moment rotate. Let me show you what I mean. If you're looking over here, this over here is an open cam and this is a closed cam. What I'm trying to represent over here, this will be a closed cam and this will be an open cam. If a wire comes in, it gets connected to here, and then, well, it will continue out to some other permissive. So let's do this one over here. Over here, now this one, it will be connected to the top, and here no power will go through because it is open, because the valve is at 25%. As the valve starts trying to open, somewhere about 90%, this cam will rotate. Now, as the cam's rotated, now it closes this contact, and power will freely flow from this point to the next permissive. If you will, this one represents this one over here, and this one represents this one over here, and they are about to rotate. Let me show you. And they just finished the rotation, opening this contact and closing that contact. In a moment, I'm going to show you these limitors, and it's actually going to be 4 of them. 2 at the bottom, which I didn't bother to draw, and 2 at the top. Now, all the way in the back, in the video, you're going to see that they got this little, well, star screw at the back. That is used to adjust whenever this becomes aligned. And earlier, I did say that when it gets to 90%, somewhere, this one is supposed to rotate. Now, eventually it gets to 100%. When it goes on the way back to try to close the valve, then what's going to happen is once it gets past 90%, this cam should rotate back to whatever position was prior. And then when it gets all the way to about 10%, then it will be this one. So this one over here per se rotates at 10%, and this one rotates at 90%. Now the setup that you have on board your ship might be a little bit different, but the theory is the same. Now on the back there is a gear system that is actually connected to the motor and to the stem, and as the stem is going down, those gears, they transmit those motion to these cams. And as long as this screw is all the way out, that means this cam and that cam is engaged to those gears over there. If I were to take a screwdriver and I stick it all the way there, and I start to make this guy go all the way in to becomes flush, what's going to happen is it's going to disengage both of these cams. At that point on, I can take a screwdriver, but that would take too long. I'll take a drill, and that's what one of my technicians will be doing, and it will be just drilling for a long time, maybe 3 to 5 minutes until this thing rotates. And the reason why we're doing this is because this cam is supposed to rotate at 90%, but it's not doing it. It's rotating when we are at 35%. That's a no-go for our scenario. So we're just gonna keep rotating this thing until finally it rotates at 90%. To save that, first, in our case, we're gonna place our valve at 90%, and then once we verify that on a dialer, then that's when we stick a screwdriver, we rotate it until we have this thing rotates. This will rotate independently because, well, this will be flush, that means disengaged, and we are only affecting the rotation of this one. If we need to adjust this one, well, then after we leave this one alone, we will have to, once again, take out the screw out, not take it out, but just make it come out so it engages, close our valve to 10%, and then at that point on, adjust this one, assuming that this one wasn't rotating at 10% like it is supposed to. So let me show you how that happens. So here to the left we got the schematic, and first thing I want to start talking about is here we got our open and our closed contact coils. Now those coils, obviously they control these contacts over here, and they determine, well, it's just a reversing system to where either it is either open or closed. And then we had these overload sensors, and then we got the actual overload switch, so that if for some reason the motor gets stuck, then electrically this will try to protect the motor from burning up. As additional protection to the motor, there are these over torque switches or cams. Well, they are actually more like switches. I will show you the overload torque switch too, and they will only open if the valve gets to 100%. When the valve is closed, then if one of these opens, then the idea is that, well, this guy and this guy should have already be open, and they are just waiting for the overload, not overload, but over torque to simply just open up, and that will stop the valve. If it's opening, then there is only one to protect it of too much torque in the open direction. And look at how they show in the schematic the actual cams for the Limitorque themselves. I went and highlight them so it's easy to see, and pretty much there is always four in line that they rotate together, but that doesn't mean that all the contacts are being used. Here to the right we got our terminal board connections, and this is actually inside of the actual valve. That's what we're gonna be mostly focusing. And then this is how they actually, this representation over here, this four over here is what I mean that they rotate together, and these four rotate together, and these things is the same thing as these guys over here. Now technically the valve has capability for a total of 16 connections. That doesn't mean that all of them are used. And then here is where they actually draw the over torque switch, limit switches. And this is useful for us to know exactly where wires should be placed, because this is a wiring diagram. Now this is a schematic. Schematics are useful is for troubleshooting. Then in here they are telling us that they got remote operations, and that means that the monitoring station, in case there is a main steam leak, there is a major casualty from far away, they can just close the valve and in that way save the life of many sailors in the space. This is a wiring representation of these switches over here. The only difference is that in here telling me that a stop and a start and a light switch are connected together. Well, actually, you know what? This is a close, 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 close. It's only one open. So pretty much the chief engineer or the EL is the only one that can open it, but all the other stations are just to be able to stop it, and then they show an indication, and that makes sense because it is for in case of casualties. They want somebody to be able to, whosoever can get first to close the valve electrically, well, that might be the one who saves the day. Now the contactors, as I will show you, they are actually at the motor controller. these cams, they are actually on the valve, which is the cams and the limit torque switches, and the push buttons, they are far away. I actually didn't record them, but they're just push buttons outside and multiple places within the space, and it is a large space. Now let's look at the valve. The controller for the steam valve is very simple. We got our opening contactor, our closing contactor. Maybe I got it backwards. Obviously our low protection on our schematic over here. Let's talk about this. Alright, so in a moment we're gonna adjust our Limitorque, but as we are doing that, we're gonna talk about the torque switches. So the torque switches, they first of all, they have these settings here. Okay, we always keep ours for safety at 1. You can always increase it to higher. Now, how does the torque switch works? Well, first of all, inside there is actually gears that, as they are rotating this thing, which is rotating our Limitorque, also when the valve is either open all the way 100% or closed all the way at 0%, there is the shaft will cause this little shaft to rotate. And what I mean is that shaft. All of that's connected internally. So the whole thing will move. See how I'm actually physically moving that? There is a little notch over here that engages. I'm just trying to get my zoom right. And it opens a contact. This is the contact that I was opening. This is a closed switch over here. This switch is not being used. It's a closed switch. And same principle, that is open. So whenever the valve over torques because it's opening way too much, then like I said, this notch will come down and it will engage. It just is hard to turn. This notch will engage and it will open the switch. Now, be mindful that this type of setups, they actually got 2 switches on the side. So this is one set, and this is another set of normally closed switches. In our case, these ones are being used. These ones are being used, and safe to say, to the other side, it just looks the same way. Down there are the switches, and I'm pushing it down right now. Is it done? Okay. All right, so it looks like they're telling me that the valve is already adjusted, the Limitorque, remember, but they adjusted. I'm just verifying that they tied that center screw, or rather they engage it. And the way how I know is because it's out, that's out, and that's out. So that means that the cams are engaged like they are supposed to be. Another way to check to make sure that they are engaged is that you can stick a screwdriver and try to turn those screws in the back, and you shouldn't be able to turn it. That means that they are engaged to the whole mechanism. Here on top of it, we got our top view, and we got the contacts. This is not being used, that is being used, and they go side to side. And the best example is this one over here. See how this contact is the same one as this one over here, and then you got these little notches, okay, that are built into this this cam, and right now it's shorting it. Whenever it rotates, then it will, well, in this case, open, and the next one is actually fixing to short. Oh, there, on the back you can actually see the contact. Waiting to rotate to actually open, make it to short to this. So currently, this is shorted, that is open, those open, and this one over here in the back that is not being used is also open. Last thing that I would like to point out is that concerning the light indications, so the way how it's supposed to work is, let's say that the valve is all the way closed at 0% open pretty much, then obviously this light should be on. But as the valve starts opening, when it gets over here, you will actually get a open light on, and so it will be both a dual indication all the way, and that lets the operator know that the valve is in transition to either open or close until it gets somewhere over here at 90%, and that is when you will lose this light. And then that way the operator knows, like, hey, you know what, the valve is almost 100% open, until finally it will stop opening because it will hit the torque switch. And the valve starts to close, obviously behaves the same. It just that starts with an open light, dual indication, and will end just with a closed light.